Okay, last section we saw the idea of limits in the terms of figuring out the slope at a particular point. We saw that we got closer and closer and closer to the value of the slope that we wanted as we took smaller and, trying to work with smaller different changes in x. So now we're going to look again at this idea of decreasing our change, or looking at this idea of limits. First of all, just to remember what we've talked about limits before, but a limit is the value that a function approaches for a given value of x. Okay, move over a little bit there, sorry about that. And then we're going to go ahead and remember how we write out limits. So this is what a limit is. As we're getting closer and closer to a particular value of x, we look and see what the value of the function approaches. Our notation is what we saw when we did our limits in terms of n behavior. We write down LIM, and we talk about what value the x is approaching, so we fill in this little box here. And then we give the value that the function is approaching, and we fill in the second box. Okay, and you see a bunch of those below. That's what we're going to be looking at. So now we're going to look at how do you determine a limit graphically. Okay, you'll notice in the direction or in the title that we're going to look at it numerically as well. Graphically, if we're looking at a limit, we're looking at reading the value of the function. The value of the function, remember, is the y value. The first problem asks us to find the limit as x approaches 0, and then it has this negative here. That negative to the right that's written like an exponent means we want to approach 0 from the left side. Okay, you'll notice here in the next problem there's a x approaching 0 with a positive or a plus as an exponent. That's indicating that we want to approach 0 from the right side. Okay, and so graphically, as we look at that, if I'm approaching 0, so we look at where x is 0. Here's where x is 0, right along the axis. If we're following this function as we approach 0 from the left side, it's coming closer and closer and closer and closer and getting closer to the value 1. From the right side, I don't need to look far from the right, but I have to approach it from the right side, and I look, it's getting closer and closer to a y value of 1 as well. If I'm looking for the limit as x approaches a particular number, in this case 0, and I'm not talking about specifically the left side or right side, but just approaching 0 in general, that means I'm looking at it from both sides. As long as the limit from both sides is the same, on both sides the function was approaching 1, then the limit at 0 is 1. Okay. Let's look at what happens around 1. 1 will give us a little bit more clear idea of this left side, right side. So here it says, what's the limit as x approaches 1 from the left side? So if I come from the left and I get closer and closer to an x value of 1, my function's approaching the value, it looks like about 2. But if I'm coming from the right side, following the graph from the right towards the value of 1 for x, the function's approaching 1. When it asks for a limit for the function as it approaches 1, if it's different on the left side and the right side, then the limit does not exist, DNE. Okay? This is because it's different on each side. It's different on the right and left side. Okay, so why don't you try, well, let's look at this next one together since it is a little bit different. It says the limit as x approaches negative, or 2 from the left side. This is not negative 2, it's 2 from the left side. So here, I'm approaching 2 from the left side, so here's x of 1, x of 1.5, because of 1.75, so I'm getting closer and closer and closer to 2. We see the pattern of this graph. We see that it's going down, and it looks like it's going to continue forever, going downwards. This is kind of like our end behavior. And we talked about this before, the limit of the behavior around the asymptotes. Here we see an asymptote. As we approach it from the left side, we're going down towards negative infinity. We could put that it does not exist as well, because it's not actually a real number. Okay, the limit is undefined, but it's not an actual real number. Here, as we approach from the right side, we're going up towards positive infinity this time. Again, we can put does not exist. Okay, this is because it's not a real number. And then definitely for our limit, sorry, this shouldn't have a minus here because we already did that. That should just be a 2, so cross that off. The limit as x approaches 2. The function's value does not approach one particular value. It's different depending on which side you come on. So we're going to say that this does not exist. This one is definitely not existing. If they're looking for limits that are real numbers, then you want to say it does not exist for the other 2 as well. Okay, here's a chance for you to try practicing it yourself. Before I let you go to practice it, though, I want to add a couple of problems in. I want a number 16 that says find f of 4, and a number 17 that says find the limit as x approaches 4 for this function. Okay, pause the video now and allow the students to have some time to work out these problems. Once they're done, go ahead and start it back up. Okay, hopefully we've completed these problems. Looking at number 10, it asks us to find the value of the function at 1. So we look at 1, and above 1 we see an open circle, which tells us the value is not there. Instead, it's up here at this closed circle, giving it a value of 2. The limit as x approaches 1, though, is different. As we look at 1, the y values for the function, the value of the functions, are approaching 1 from the left side, and then on the right side, they're also approaching 1. The limit has the value 1, because on both sides, the value of the function is getting closer and closer to 1. It does not actually depend on the value of the function itself. It depends entirely on what the value of what the function is approaching for that particular x value. Be sure to have that clarity in your mind as you think about a limit. Now as we look at f of 2, that's saying what's the value of the function at 2. Above 2, we see the closed circle at 2. Then it asks for the limit at 2. What we notice is what you notice below, that from the left side, the value of the function is approaching 2. From the right side, it's approaching 3. It's not approaching the same value on both sides, so the limit at 2 itself does not exist. Okay, then we look at the function around the value 4. First of all, notice there's an open circle and nothing else to give me a defined value. At f of 4, the function is undefined. But the limit does exist. As we approach 4, the value of the function gets closer and closer to 2 on both sides. So the limit exists even though the value of the function is undefined. Okay, we'll go on to the next video and we'll look at the back side of these notes.